We welcome you all to the Department of Metallurgical and Materials Engineering, IIT Roorkee. The department was established in 1963 with the intake of 60 students for the undergraduate curriculum leading to bachelor's degree. Later, the post-graduation curriculum was started in 1969. The department has been actively involved in research since its inception, and the first award of PhD degree is recorded in 1972. Earlier, the faculty members were engaged in research in the areas of physical metallurgy, thermodynamics, and the kinetics of metal extraction and powder metallurgy.
In the early 70s, a number of new faculty members joined and started activities in the areas of ferrites, composite materials, and coatings of amorphous and microcrystalline materials. It was increasingly realized that the barriers between metals, ceramics, and polymers need to be broken, and an integrated approach to materials should be evolved. The name of the department was changed from Department of Metallurgy to the Department of Metallurgical and Materials Engineering in the year 2001, with the introduction of courses in polymers and ceramics in the curriculum level.
Presently, the tremendous development of materials technology and across all the materials, the present barrier of the, or you can say the earlier barrier of the metals, ceramics, polymer and composite materials or any other specialized material that has already been broken. And more venture will take place that there is no clear-cut barrier. Because if you want to talk about the applications of the materials technology, it has to serve across all the temperatures and different service conditions and these. So therefore a particular material will not be satisfying the requirement. It can be suitable for a region of temperature or over a region of the service conditions, but it will not be no.
At present, there is an intake of approximately 100 undergraduate students per year. Apart from degree program, department also offers master's level specialization in materials engineering and industrial metallurgy. Our students regularly get academic, technical and professional exposure through international student exchange programs.
It has been such a wonderful journey here, and I got a lot of learning opportunities in my lab and through the courseworks. The student-faculty interaction is just wonderful. I got a lot of opportunities to go to abroad through the department, through various collaborations like student exchange program. I went to KTH, Sweden, and that was a wonderful learning experience in the international environment. I would like to thank this department for giving me such a wonderful opportunity.
I joined here as a master's student, and I thoroughly enjoyed the experience of all the first year through the courses that I have learned here in this institute. And thanks to the collaboration of my professor with the German guide, I was able to complete my master's thesis in Germany as well. So here I got the experience of the best of the institutes available in India, and also with the help of my professor I was able to taste the research of the abroad.
It has an intake of approximately 15 research PhD scholars every year from various backgrounds, and they are involved in cutting-edge research in different fields.
This is our energy materials lab, and basically our team is working on lithium-ion batteries. And for that we have various instruments like carbon instrument is there, and conductivity measurement instrument is there, and we have some Kitle instruments which are used for the Wagner polarization techniques.
We talk about the carbon nanotube. We know that the carbon nanotube is the accelerate material as a function of mechanical strength, electrical strength, and also thermal stability. Generally, a basic approach to transfer these type of properties into the polymer is the reinforce of the polymers with the help of the carbon nanotube. And during the formation of the carbon nanotube reinforcement into the polymer matrix, generally one difficulty which is very important is the low dispersion of the carbon nanotubes and in polymer matrix. Generally in our work we are trying to set up an approach from which we can make homogeneously, uniformly and molecular dispersion of the carbon nanotube in any kind of the polymer matrix.
Usually, the department is providing consultancy and testing facility to public sector as well as private sector units in this state and around it. Department handles high-level research projects sponsored by DST, DRDO, BRNS, CSIR, NRB, DAE, ONGC and other funding agencies. Department is actively involved in collaboration with BARC, DRDO, ISRO and DMRL.
department is providing testing and consultancy facility to private sector as well as public sector. In public sector like BHEL Haridwar, it comes regularly to us for their problem like failure analysis of their turbine parts, especially in our scanning electron microscope, and Uttarakhand Jal Vidyut Nigam, they come for their investigation of their parts, especially some of the chemical analysis of the parts which they are using and they want to develop the substitute material. They require chemical analysis, which we do with the help of a spectrometer. Plus, we also provide technical know-how about the failure analysis of various components. Like recently in Uttarakhand, in Srinagar, GVK group has called us for the investigation of a component in hydro turbine in Srinagar GVK group, hydro turbine plant.
The focus of the department is on the development of advanced materials. The significant work has been done in the area of failure analysis, development of ultrafine grained materials, nanostructured coatings for corrosion resistance and tribological applications, metallic and polymer matrix composites, spray forming, powder metallurgy and friction stir processing. The development is actively involved in collaboration with Department of Electronic and Communication of our institute in the development of radar wave absorbing materials for stealth planes. Efforts are being made to apply nanomaterials for developing water purification technology and e-waste management. Process development for joining of dissimilar materials is being carried out.
From material development point of view, aluminium-based metal matrix composite, cryo-roll ultrafine grain, zirconium-based alloys and creep-resistant steel are also being developed for structural applications. For hydroturbine application, especially for Uttarakhand region, erosion-resistant stainless steel are being developed. From energy point of view, work on metal foam, lithium-ion battery, etc. is also being performed. Recently, research has been initiated on the development of biomaterial for orthopedic implant and electronics material for field emission and solar energy.
We are working on different kind of nanomaterials, including carbon nanotube and graphene, and some other nanomaterials which we are using obviously depend on some oxide-based nanomaterials. And this is being used for many applications. One of the important applications is field electron emission, which has a lot of potentials in displays as well as on microwave generation systems. And further, we are also using these nanomaterials for solar cells, some for lithium-ion batteries. So this is looking to be a very important field for future also, and many of the students are working actually in this field. So I hope this is going to be very important for all of us.
There has been interaction between our department and Department of Mechanical and Industrial Engineering, Center of Nanotechnology, Electronics and Computer Science, Alternate Hydro Energy Center, Chemistry and Physics for the joint guidance of research work in the interdisciplinary research areas.
In order to raise the level of research at par excellence with international standards and for better technical interaction, various international and national conferences are organized by department at regular intervals. Department tends to provide enough research facilities with modern sophisticated equipments such as thermomechanical simulator, SEM, EDS, XRD, nano indenter, HRTEM, SPS, micro hardness tester, DSC, DMA, dilatometer, indentation creep, attritor mill, pin on disc tribometer for research activities in the various areas of materials.
What we are standing in front is a spark plasma sintering machine, which the department has procured this year, which is an advanced sintering system.
Our students are also active in taking part in international professional societies like Materials Advantage and our own professional society, Metallurgical Engineering Society, METES. Apart from all these academic and technical associations, our students are also involved in social mixing and cultural activities to make their stay over here memorable.